I will show you in this video how to do what the directions are for this worksheet. As you can tell, there's just 3 problems here, and each one looks very elementary. So you're probably, if you're guessing that you're not just solving 3 problems for this worksheet, then you are correct. I don't want you to just solve 3 problems. I want you to do more than that. What I'm going to have you do is a series of problems for each number. So the first thing you're going to do is you're going to calculate what the sum of 8 plus 3 is. So 8 plus 3 is 11. So that's the first thing that you need to do. You need to figure out what the sum is. From there, you're going to use properties of addition that we've talked about in order to walk yourself through some problems where you have sometimes you make both add-ins negatives, sometimes one of them is negative, and I will show you what I mean by that now. So the first thing I want to write down is addition is commutative. And it may be good for you to take notes on this video so that you can reference the notes later when you're gonna go back to do this. I am gonna do number 1 for you here, but you'll see that it'll get kind of involved and it'll be hard for you to remember all of these things when you go back to try and do this on your own. So the notes will really be helpful to you. So going back to what I was writing in here, addition is commutative. Right, commutative is a big fancy word, but all it means is it comes from the word to commute, and commute means to move. So what this means is, for example, if you have like 4 plus 3, that would equal 7, and 3 plus 4 is equal to 7. So the order in which you add the two numbers, the add-ins, doesn't matter, right? The two add-ins are the numbers being added. Those are called add-ins. So the order of the add-ins does not matter for addition, all right? And this makes addition awesome and really simple to use as an operation. So that's the first thing that you're going to do. You're going to use this property, addition is commutative. You're going to go to second line, insert equation, and you're going to write down 3 plus 8 is equal to 11. All right. That's good. From there, you're going to move on to the negatives. If you had negative 8 plus negative 3, that would be negative 11. There's some symmetry with the number line. Symmetry about 0. I'm going to write down the number line is symmetric about 0, right? So if I'm working with just positive numbers, if I'm adding positive numbers, I'm on the right side of the number line, and I add 2 numbers, my solution is the sum of these 2. It's bigger than either one of these alone, right? But when I'm working on the left side of the number line with just negative numbers and I'm adding them, then my answer is going to be the sum of the 2, and it's going to be even further in the negative direction than either one of these 2, right? But now addition is commutative. Again, addition is commutative. It doesn't matter if the numbers are that I'm adding are negative or not. Addition is always commutative. So negative 8 plus negative 3 is the same as negative 3 plus negative 8. That's going to equal negative 11 as well. And from there, you're going to use another property that we've talked about. And the property is that subtracting a number is the same as adding the negative of that number. That's the next thing I want you to use in the next equation you're going to write is going to use this property, that subtracting a number is the same as adding the negative of that number. So you're going to take this equation and you're going to express this as negative 8 as a subtraction problem. So adding the negative of a number is the same as subtracting the number. Right? Minus 3 is the same as plus negative 3. Subtracting a number is the same as adding the negative of that number. So this is going to be the same as this one. Both are going to equal negative 11. And now you'll do the same thing for this problem. Negative 3 plus negative 8 is the same as negative 3 minus 8, because subtracting a number is the same as adding the negative of that number. They are both equal to negative 11, right? So far notice I'm creating groups. These two equal, these are the same, both equal 11. I've got another group here of 4 problems where they all are equal to each other, right? First 2 are equal through the fact that addition is commutative, and then the last 2, I use this property, subtracting a number is the same as adding the negative of that number. So these 4, looking at those 4, you'd say these all have the same sum or the same answer. Now what you're going to show is that subtraction is not commutative. Addition is, but subtraction is not. Subtraction is not commutative. So if we have 8 minus 3, sorry, I'm going to go to insert equation. 8 minus 3, that's going to equal 5. And we know that, insert equation, we know that subtracting a number is the same as adding the negative of that number. So we will rewrite 8 minus 3 as 8 plus negative 3. That's going to equal 5. And we know also that addition is commutative. So I'm going to go to insert equation and flip the, switch the addends. I'm going to put negative 3 first. Negative 3 plus 8 is positive 5. And now I'm going to do the other subtraction problem. 3 minus 8. Subtraction is not commutative. So 8 minus 3 is not the same as 3 minus 8. 3 minus 8 is going to be negative 5. It's going to be the negative of this answer, right? If the number, smaller number comes first, then your answer is going to be negative because of the way subtraction works, right? If you're going to go subtract 8 from 3, then you're going to start at 3 on the number line. You're going to go 8 units in the negative direction. You will definitely pass 0, so you're going to start walking in negative territory. You will land at negative 5 if you walk negative 8 units to the left of 3. So now let's show that subtracting a number is the same as adding the negative of that number. And lastly, let's show that addition is commutative. All right, we're gonna rearrange the addends, change the order of the addends. And that is all. Those are all the equations that I want you to list for each question, right? There's 2 sets of 3, 1 set of 4, and 1 set of 2 equations. 1, 2, 3, 4 groups. Okay, and all you're doing is you're using these properties of addition. Addition is commutative. Subtraction is not commutative. Addends, those are just the numbers being added. The number line has symmetry about 0. And subtracting a number is the same as adding the negative of that number. All right, those are important things for you to know, to understand, and to be able to use and to use to your advantage. Right, the way you could use this to your advantage, say you had like a difficult problem. Say you had negative 19 or negative 99 plus 45. And you could look at that negative 99 plus 122, right? And you'd look at that and you'd say, what is that, right? When I first taught you how to add negative and positive numbers, I told you about 0 pairs. And if you don't know what a 0 pair, if you don't remember, then yeah, this might be a real struggle for you to figure out how to do this. But what you could do is you could say addition is commutative. So this is, I could rewrite this as 122 plus negative 99. So just switch the order of the 2 addends. And then you could say adding a negative number is the same as subtracting that number. So this is the same as 122 minus 99. And then you're just doing subtraction. You just stack the numbers, right? 122 on top and then 99 below it. And then you just subtract. So you subtract 2 minus 9. You'd want to borrow from this 2, right? You guys remember that algorithm. So this one is doable. This one might be confusing for you, but this one is doable. So using these properties can work to your advantage. And I hope that you use it to your advantage in the future with problems when you have to do integer arithmetic. Don't forget at the end, when you are finished, you want to highlight your work and go over here where it says text color and choose a color for your work other than black or red. I also don't want you using red. Please don't use red. And at that point, you will be finished. All right. Make sure you do your problems in the order that, make sure you do each equation in the order that I did it. You shouldn't have this one be like here or anything. Right, you shouldn't, I just mean that this one shouldn't be like here, and this one here. They should be in the order that I solved them in this video. So if you write down, say you have a notebook out with you, you can write these notes down on a piece of paper or in your notebook, and you can write this example in your notebook and then just follow that example for number 2 and 3. The goal here is really for you to